Testing 1 2 3, testing 1 2 3. Okay, I will just wait a while more and see if more people will join us. Okay, I guess that we shall begin now, right? Because it's 4:30 already. Okay, thanks for tuning in to this stream here. So we'll go through firstly the round two junior questions for the RMO. Now, the RMO round two junior questions, there's a big overlap in the questions together with the open round two questions. So later on, when we are doing the open round two, we will not be repeating those questions which we have gone through over here, right? So that particular one will be much shorter than this one right here. Okay. Anyway, let's start with the questions. So let's begin. Also, if you have any questions, you can also put it in the chat, and hopefully I'll be able to see the messages that you send in the chat on YouTube. Okay, question number one. There is a positive integer that's less than 100. What's the largest possible value of this integer given that it cannot be written as ab plus a plus b? So the question becomes, what kind of numbers can be written as AB plus A plus B? The idea is that AB plus A plus B, if I add that 1, this is of the form A plus 1, B plus 1, right? Which can be factorized into such a form here. Now take note of something in this question. The question actually, what it means is that A and B are actually positive integers. Right, so this is one of the missing conditions here. So A and B are positive integers. What happens if I have AB being positive integers and then A plus 1 times B plus 1? It means that this thing here is not a prime, right? Because we know that it will be something that is at least the value of 2 times something that is at least the value of 2, right? So what are we looking for? We are looking for a number that when we add 1, it is not a prime. Sorry, it is a prime because I want it to be not written as this. So if I want it to be not written as AB plus A plus AB plus A plus B, what does it actually mean? It means that if we add 1, oh, sorry, if we add 1, it is a prime. Right? It cannot be factorized into two numbers which are all at least the value of 2. So what numbers that if you add 1, it is prime? So 100, we know 100 plus 1 is a prime, right? But unfortunately, the question says less than 100. So 100 plus 1, nope, right? Because it's too big. What about numbers such as, let's say, 99 plus 1? 99 plus 1 is 100. It is not a prime. 98 plus 1, it is 99. It's not a prime. 97 plus 1 is 98. It is not a prime. 96 plus 1 is 97. Is a prime. Right? So what that means is that 97 cannot be written as this form here. So that means that 96 cannot be written as AB plus A plus B. So therefore, the final answer for this question is equals to 96. Okay, let's move on to question number 2. Question number 2 says the following. For a positive integer n, we call it a Raffle prime if it becomes a prime number when reading backwards. For example, 76 is a Raffle prime because when we read backwards, we get 67, which is equals to a prime number. What's the largest possible value of n where n is a two-digit number and n, 4n, and 5n are all Raffle primes? Okay, so we want the largest possible value of n, right? So what we can do is that we can try to draw some kind of diagram for n. And in that case, I can also look at it for 4n, I can look at it for 5n. Now, I want to make sure that when I reverse it, these are all prime numbers. So what's the largest one we choose? 99 when reversed is 99, is not a prime number. We can try to do 98 because 98 when reversed is 89. Now, in that case, 4 times of 98 will be equals to, this is 392, right? And then when we do 5 times of it, I add a 98 to 392, this is equals to 490, right? Now, there's already a problem. The problem is that if I reverse this digit, right, if I reverse, is 094. The problem is not with the 0. The problem is with the 4. If the last digit is a 4, we know that it will never be a prime number, right? So this works for all the values of n up to a certain point. For example, if you try, let's say n equals, let's say 91, for example, right? If you try 91, 5 times 91 is equals to 455. If you go and reverse it, it is still gonna end with the digit 4, which will make it not a prime number. So what do we want to do? We want to make sure that 5n firstly is less than 400. So our n value you want to choose is no more than 80. So we can immediately skip all the values from 99 to 80 because I know that 5n will all start with 400, right? So let's try n equals to 79. If n equals to 79, firstly, if I reverse it 97, yes, that's a prime number. If I have 79 here, 4 times 79 is equals to 4 times 80 minus 4, that's 316. Okay, seems to be okay. If I reverse 613, maybe it's a prime number, we don't know yet. If I have 5 times 79, that's going to be 400 minus 5, that's going to be 395. If I reverse, it's 593. Possible, right? So it seems possible that this is a case where you have both prime numbers. So let's check 613 and 593. So what do we need to check? We need to check 2. Obviously, they are both not divisible by 2. We need to check 3, which they are both not divisible by 3 if you check the sum of digits. You can try 5, you can try 11. These are all obvious. If you try 7, after some time, you figure out that both of them are not multiples of 7. What's next you need to try? So after you try 2, 3, 5, 11, 7, you need to try 13 as well. If you try 13, actually you can realize both of them are not divisible by 13. Try 17. After some time, you realize both of them are not divisible by 17. Try 19. After some time, you realize both of them are not divisible by 19. And finally, 23. After some time, you realize both of them are not divisible by 23. So therefore, actually, both of these numbers are primes. So therefore, actually, the case where n equals to 79 will be the one that works. So the largest value of n here will be equals to 79. Okay, let's move on to question number 3. How many integer values of y over x are there such that 11 over 2025 is less than 2x over x plus y, less than 13 over 2025? So they say that y over x is an integer value, means that y is multiple of x. Right. Now, what I can think of that is I can think of it as y equals to some number times x, where this n is equals to a positive integer. So in that case, what do we do? Well, we can see that the number below is actually going to be n plus 1 times of x, and this is 2x here. Now, how do you estimate 2 over n plus 1? It is not easy, right? It will be much easier if we can estimate the value of n plus 1 over 2, which is done by flipping this fraction upside down, isn't it? So what that means is that I want to flip both 11 over 2025 as well as 13 over 2025 upside down as well. So let's do that. So we want to calculate 2025 over 11 and 2025 over 13. Here, there's something that can help us calculate both of these. If you know 2002 is equals to 2 times 7 times 11 times 13, right? Wait, I wrote this a little bit too high. You may not be able to see. Okay, let me drag it down here. So what that means is that if I look at the number 2025, it is 23 more than that, right? So it's 23 more than that. So it's 23 over 11 more than 2 times 7 times 13. 2 times 7 times 13 is 182. 182 plus 23 over 11. This is 184 and 1 over 11. Now, 2025 is the same number plus 23. So this time it will be a little bit less than 26, which is 2 times of 13. So this is equals to what? This is 2 times 7 times 11. That's 154 plus 23 over 13. So that's going to be 155 and 10 over 13. Okay, so recognize that this number n plus 1 over 2 must be in between 184 and 1 over 11 and then 155 and 10 over 13. Now, how many choices are there for this value of n? Right. So we notice that I can write out as n over 2 plus half. So n over 2 it is basically like a multiple of, sorry, it's a multiple of half, right? So you can think of it as maybe a whole number with or without a 0.5 at the back. So what's the first one you choose? So the first one that this one will work is when it reaches 156, right? So this one can be 156, all the way down to 156.5, 157, 157.5, all the way down to the last case being 184. These are the possible whole numbers for your, not whole numbers. These are possible values for your n over 2 plus half. Okay, so how many values are there here? The number of values here is equals to 184 minus 156 divided by half plus 1, because the gap is half, right? So if you take a look at what this is, you can get 28 divided by half is 56 plus 1. The answer is equals to 57. There are actually 57 values of this n, which means there are 57 values of your y over x. Okay, question number 4. Question 4 is a funny looping question where they have basically this 1 minus 1 over 3 squared times 1 over 4 squared minus 1 all the way until 1 minus 1 over 2025 squared. Now, this question here is actually a question that uses difference of squares. So how to apply difference of squares in question number 4? We can use the idea of 1 minus 1 over x squared. This thing here can be factorized as 1 minus 1 over x times 1 plus 1 over x. So what we're going to do is that firstly, we're going to sort out the order of each of these numbers. How many of these terms are in the opposite order, where it is the smaller number minus away the bigger number? Well, these are the ones that are even, right? So those that are even are the opposite order. So how many even numbers are there from 2024? From 4 to 2024. There's 2024 minus 4 divided by 2 plus 1. This is going to be 1011 evens. So if 1011 even numbers, what does it mean? It means that I can first write it as 1 minus 3 squared. 1 minus 1 over 3 squared, 1 minus 1 over 4 squared, 1 minus 1 over 5 squared, 1 minus 1 over 6 squared. I flip all of them back, but then I put a minus sign in front. Because if you flip the sign of 1011 numbers, overall, you still become a negative number, right? Okay, so if I flip this minus sign there, then what I can do is that I can continue calculate this using our difference of squares. So it's a minus, the first term here is a 1 minus 1 over 3, 1 plus 1 over 3, then 1 minus 1 over 4, 1 plus 1 over 4, 1 minus 1 over 5, 1 plus 1 over 5, and so on. Okay, until the very last term. Now, if you go and calculate out each of these terms, what it gives us is the value minus 2 over 3 times 4 over 3 times 3 over 4 times 5 over 4, and so on. Right. So our students definitely have seen this question before. It is within our P5 syllabus, especially the thing about the called the partial fractions, right? That particular worksheet we talk about this. So 2024 over 2025 times the last one is 2026 over 2025. Now you might notice that some things can cancel, right? The 4 over 3 and the 3 over 4 can cancel out. The 5 over 4 and 4 over 5 can cancel out. 6 over 5 and 5 over 6 can cancel out. All the way until the one before 2024 over 2025 can cancel out with the one that is 2024 over 2025. And there you have it. The final answer of this question is minus 2 over 3 times 2026 over 2025. And if you just quickly take a look at these numbers, you can see that none of them can really be cancelled. So the answer for this question will be this number here, right? Negative of the 4052 over 6075. Okay, let's continue with the next question, number 5. Question number 5. There are three squares inside a triangle as shown below. The area of the squares are 1, 4, and 9 respectively. Find the area of the big triangle. Now, firstly, the idea behind this question is that the 5 small triangles that you can see in the diagram, they are all similar to each other. How come? As labeled, the side lengths of these three squares are 1, 3, and 2. So it's not hard to see that this one will be 1, and this one will be 3 minus 1 equals to 2. On the other side, 3 minus 2 is equals to 1, and then 2 is equals to just 2, I guess. Yeah. So both of these triangles here, these right angle triangles, they are a 1 by 2 right angle triangle. So they are in fact the same right angle triangle, right? So they are congruent. Now the rest of them will all be similar to this triangle, right? It's easy to see that the one in the bottom left will be similar to this one as well. It's easy to see that the one on the bottom right will be similar. The only question is left is, why is the triangle on top also similar to all of these triangles? The reason is quite simple, because of the parallel lines. Because of the parallel lines, this green angle over here is equal to this green angle. And because of the parallel lines, this purple angle over here is equal to this purple angle. Right. So therefore, the angles that are from this triangle are all the angles that are from the red color triangles. So actually, this triangle is also similar to everything else. Okay. So if these are all similar triangles, then it becomes quite simple for us to find the areas of each of these 5 triangles. For example, right, the one on the bottom right, it will be twice the shape of this one here. How do I know that? Because this time the vertical length here is equal to 2. So therefore, this is a 2 by 4 triangle. In a similar way, this is a 2 and then this is a 1. So it means that this is a 0.5. So on the left side, we have this half by 1 triangle here. What about the triangle on top? Well, the triangle on top is a little bit special because it doesn't really relate to everything else. However, we know the triangle on top has a hypotenuse of length 3, right? Because this thing here is equals to the value of 3. And if you compare with the other triangles where we have 1 and 2, you know that the hypotenuse will be square root of 5 in this case. Okay, so if we know the ratio of the hypotenuse, we can also go and find the ratio of the areas, isn't it? And then we're done with this question. So the rest is just calculation. So let me do some calculation here. The areas of the squares are 1, 9, and 4, right? The area of the one on the left is equals to exactly 1/4. The area of this one and this one, they are both equals to 1. The area of this one is equals to 4. And finally, what's the area on top? We can see the side length is 3 to square root of 5. So the area ratio will be 3 over square root of 5 squared of the area of this triangle. Now the area of this triangle is equals to 1. So actually just nice. It is 3 over square root of 5 squared. Okay, so that's the value here. Now add up everything and you should be able to find that the final answer for this question will be the numerical value 22.05 if you go and add everything up together. And that's the answer. Next question, number 6. Number 6, this is basically almost exactly the same as one of the logic questions we had in our worksheet before. Right? If you've taken the particular logic worksheet, you would have seen this question before. So before announcing the result of a competition that ABCDE participated in, Mrs. Lim asked each student to guess 2 of the other students' placing. Blah, 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 blah. If each of them had exactly 1 guess correct, what's the order of their placing? So where do we start? Well, to me, it is pretty obvious that we should start from the condition that E is fourth. Because this is the only condition that oh, okay, actually I realize now that actually there's another condition that repeats. So you can actually start with either one. You can either start with this pair, or you can start with this pair. It's up to you. Alright, so for demonstration purpose, if you want it to be a little bit different, let me start from this pair then. Okay, let's say I take a look at this pair of conditions. So what do we do here? One thing we can do is that we can assume they are either both correct or they are both wrong, right? Let's say that D is infected. Yeah, let's say that D is infected. If D is infected, what happens? Then this is correct, Correct, wrong, wrong. So E is fourth is wrong. So C is first is correct. Right? C is first means that D is first is wrong, means that B is third is also wrong. Then you have a problem. Because suddenly you see that the second row, there's no condition that is correct. So if D is third, you come to a contradiction with the conditions, right? Because you realize that hey, B cannot have any one of them correct, right? And if B has one of them correct, that means that either C, D, or E has one of them being wrong. So then let's reset back to our starting assumption. If there's a contradiction for D is third, then what do we recognize? So it must be D is not third place. Okay, so in fact, this is wrong, this is wrong, this is correct, this is correct, this is wrong, this is wrong. So now next, you can go back up and, oh sorry, A is second is correct. And then you can go back up and say, okay, if A is second, then this is wrong, so B is third and C is fifth. So what's the order of the placing? The order of the placing is that D is first, D is first, followed by okay, let me see who's the second one. A, then B, then E, then C. And this is the fifth one. Okay, let me move on to question number 7. Question number 7. A multi-digit number n has 6 as its last digit. So you don't know how many digits it has. If the 6 is moved from the end to the front, the value of the new number is exactly 4 times. So basically, we have something with a 6 at the back. If I multiply by 4, there will be a 6 in front now. Right? Find the smallest possible value of this n. Well, we know that 6 times 4 ends in a 4. Right? But what it means is that this chunk of numbers in front of the 6 is going to be the same as this chunk of numbers behind, right? Because the 6 is moved to the front. So the 6 will belong here now. But the big chunk of numbers will still be the same. So if the last digit is 4 over here, then hopefully you're able to see that this is also equals to 4. Now remember that here, 6 times 4 is 24. There's a carryover of 2. Then now what can you do? You can do this process of doing 4 times 4 is 16. 16 plus 2 is 18. So this one must be an 8. This one must be an 8 with a carryover of a 1 because it's 18. Then next you have 8 times 4. 8 times 4 is equals to 32. 32 plus 1 is 33. So this is a 3. Wrong color. So this is a 3. This is a 3. The carryover is also a 3. And then you just continue until you hit the end. So 3 times 4 is equals to 12. 12 plus 5 equals to 15. This is a 5. This is a 5. The carryover is a 1. 5 times 4 is equals to 20. 20 plus 1 is equals to 21. So this is a 1. This is a 1. And then the carryover is a 2. And finally, you realize 1 times 4 plus 2 is 6. And when you know that it's 6, you know that you can stop here. The answer is 153846. Next question. Question number 8. As shown in the figure below, we have this ABCD parallelogram with AB being equals to 13 and B equals to BC is equals to 30. So this is equals to 30, this is equals to 13. BE is perpendicular to AD and B is equals to 12. So those of you who are sharp, you can immediately see the 5, 12, 13 right angle triangle, right? So AE is equals to 5. Find the value of AG to AC. So that's what the question wants. How to do this question? So for this question, we need to know two things. We need to know, number one, the position of the point G on the line AG. Because we need to know where G is to know AG, right? Because we know the entire length AB. The second one we need to figure out is the length of AC. And AC is in fact the easier one. Right? AC is in fact the easier one. So let's start from AC. The way we can do AC is to drop a perpendicular here. And we notice that they'll be congruent. This triangle at the back will be congruent to the triangle here. So this one here will also be a 5, 12, 13 triangle, right? And that means that the base is 35. And then the height is equals to 12. So okay, so therefore we take the square of this, we can find the value of AC. Now I think this is 37, but let me just do some calculation to check first. 35 square is equals to 1225, 12 square is equals to 144, add up is 1369. Yeah, that's 37 square, correct. Yeah. So this is 37. So AC is equals to 37. Okay. So AC is equals to 37, then AG is the slightly harder one to find. Now, I know some of you here are pretty smart, right? If you're smart, you may have heard of something called the Menelaus theorem before. If you know what the Menelaus theorem is, you can use it. But let's say you haven't heard of the Menelaus theorem before, then what you want to do here is actually to use a area concept. All right, so use the area idea. So how to use the area idea? We know that the ratio along the bottom is, okay, let me draw a new diagram so that I don't confuse you all with the current one. Something that looks like this is fine. The ratio along the bottom is 5 to 25, which is 1 to 5. So let's write out 1 to 5. And then what about the vertical line? We know something else about vertical line, right? We know FE to BF. Because we know that 5 to 30 will form a similar triangle. So the similar triangle is here, right? And here, right? So this is a group of similar triangles. So 5 to 30 is 1 to 6. So we know that in fact the height over here, the vertical line here will be equals to a ratio of 1 to 6. And if you know these two ratios, then actually you have something that allows you to work with area. So what you can do is that we can close up the shape to form a triangle. We can draw this thing on the left, cutting it up, and then we can go around and label each of the sides. Right? For example, we can do 1 unit here. On the right side, this one will be 5 units, right? Because of the 1 to 5. And then you can use the arrowhead model. Right? So if you use the arrowhead model, you can see that this part is equals to uh wait, sorry, not arrowhead model yet, not yet. I skipped one step actually, which is that this is 1 to 6. So I know that if it's 5 units, this one will be 30 units. Okay. So what I also know from this 1 to 6 is that this part here is 6 units, but I don't know how I split these 6 units up, right? So then we can use the arrowhead model on the right side. So the arrowhead model says, I can take a look at this 30 units, right, to the 6 units here. And 30 to 6 is in the ratio of 1 to 5. So actually this is a 1 to 5. That's what the arrowhead model says. So if this is a 1 to 5, then where is this G? It will be split in this ratio of 1 to 5, right? So I split 13 in the ratio of 1 to 5. AG is equals to 1 over 6 of 13. Okay, and basically from here we have uh the answer for this question already. Yeah. So if we um continue, if you continue here, then the AG is equals to, okay, AG to GC, right? So AG to AC, AG to AC, that's 1 over 6 times 13 to 37. That's 13 to 6 times of 37. 6 times of 37 is equals to, I can math. What's this? 222. Yeah, that's correct. Okay, so that is the answer for this question. Let's move on to question number 9. Question number 9, the phrasing can be a little bit confusing, so I may need to explain a bit. Some students took part in a round-robin tournament. They play with each other only once. The winner of each round gets 3 points, a draw gets 2, a loss gets 1. If the sum of the points of 3 students is 26, what's the maximum number of points any student can get? So 3 students. 3 students, they play against every single person, right? which means that they must play against each other. So they must play a game with each other. So the result of each game is that each game gives out 4 points, right? And no matter who wins or whether they both get a draw, right? It will be either a 3-1, a 2-2, or a 1-3. So no matter what happens, each game gives out exactly 4 points. So within these 3 games, what you can see is that they already have 12 points, right? So for 3 students, by just playing each other, they can already get 12 points, right? At least, sorry, exactly 12 points now, not at least. So the remaining 14 is by playing other students. So if I want to have the most number of points the student can get, I want to make sure the number of students is as big as possible, right? But I noticed that because I have only 14 points here by playing the other students cannot be too many, right? So let's say that these are my 3 students, then let's say that my other students are here, right? And let's say that my other students, there's exactly n of them. Then for my first guide, I play against n people here. What's my score going to be? My score is going to be at least n, isn't it? Because I play against n other people, right? And I even if I lose all n games, I can get at least n points. So if there's other n people, then the remaining 14 will be what? The remaining 14 will be at least 3n, right? Because one person will play against the other n people, another person will play against the other n people, and then the third person will also play against the other n people. So they'll get at least 3n points. So from here you can see actually n is at most 4. Right? There's at most going to be 4 other people. So the result is that there are at most 7 people. 7 people are in the tournament. And if there are at most 7 people in the tournament, how much points can a student get? Well, it's at most going to be 6 times 3. Because 7 people means you play against 6 people. Right? If you play against 6 people, then naturally you can get at most 6 wins. 6 times 3 is 18. Okay, question number 10. You have this RRMMOO is RMO. Very creative question, isn't it? RRMMOO is RMO. Now, from this statement alone, you should have guessed that maybe R is equals to 1 already. How come? Well, we know that these 3 numbers are at most 99 plus 99 plus 99, right? That's going to be at most 200. So R must be 1 or 2. But more than that, if you remove a common letter M, let's say I remove this letter M, and I replace it with the letter 0. Sorry, with the number 0. Then what do we notice? Okay, so here I need to make sure you can understand something. The one in blue color, they are all letters. They represent, okay, actually, M cannot be 0. But let's just pretend that if I remove it, I can get 0. So O represents a letter. O can be something from 1 to 9, right? But the one in red color, I'll use numbers to represent. So the red color one is a 0, but the blue color one is O. Make sure of this difference. What it means is that R plus O, okay, maybe let me stick to blue color. R plus O has carryover. Yeah, and that means that R is going to be 1. The reason is because if R is anything else that is more than 1, if R is let's say at least 2, then you have a problem. You cannot be able to get 20 from just this number. Even if you have a carryover, you cannot get a carryover of 3. Right? So it's at most going to be 9 plus 8 plus 2. That will not allow you to have they will not allow you to have 20 here. So even though it has carryover, the carryover is exactly 10. Okay, so from here, of exactly 10, so R is equals to the number 1. Okay, so now R is equals to number 1. Now you can take a look at the last digit, and the last digit is pretty easy to see from here that M is equals to the number 9. And now the only thing left will be the digit O. So let's fill in the numbers with what you know. We have 119900 is going to be 190. Now, obviously, the last digit, it doesn't matter here, right? But you can notice the carryover is 1. So what that means is that 1 plus 1 plus 9 plus O is equals to 19. And from there, we can see that the digit O must be equals to the value of 8. Okay, so RMO is 198. Finish. Okay, next question, number 11. Calculate this question. Right. So this question is a quite nice question. I like it. The idea is to use difference of squares. So the idea is that if you have n times n plus 2, this is the same as n plus 1 minus 1, n plus 1 plus 1 is n plus 1 squared minus 1. So therefore, if I add 1 to both sides, if I say n times n plus 2 plus 1, if I add here, then the result is n plus 1 squared. So from there, if I take a look at the expression on the inside, we can immediately see. In this case, our n is the value of 2020. So our result of this will be 2021 squared. So our first step of this question will be 1 plus 2023 square root of 2011. Wait, sorry, 2021 squared. So 1 plus 2023 square root of 2021 squared. Of course, that just means 1 plus 2023 times 2021. And then, hey, the same problem repeats again, right? I know that this thing here must be equals to 2022 squared. And if I have 2022 squared, I know that, okay, the next step here will be equals to 1 plus 2024 square root 2022 squared, right? That will be equals to 2023 squared. So at the final step is the one that says square root of 1 plus 2025 square root of 2023 squared. You can see that this is just 2024. Question number 12. How many ways are there to place 7 numbers 1 to 7 in a circle so that the product of two adjacent numbers does not exceed 20? Well, if it doesn't exceed 20, you need to look up for the most restrictive one, which is 7. It means that 7 can only be beside 1 and 2. In fact, 7 must be between 1 and 2, because if you are placed in a circle, if you look at an entire circle, 7 is between two numbers. It must be 1 and 2, right? What about the number 6? 6, you can only do 6 with 1, 6 with 2, and 6 with 3, right? Because anything else will be more than 20. Now, 2 and 1 are both with the number 7. So either 6 is beside 1 or 6 is beside 2. So that means from here, I can immediately deduce there are only two cases, 17263 or 36172. Here we are ignoring rotation and flipping for the moment, right? So how many ways are there to complete the rest of the circle? We notice that 4 and 5 can be in any order. Because 4 times 5, 4 times 3, 4 times 1, 5 times 1, 5 times 3, they are all less than 20. Right? So it can be either 4, 5 or 5, 4. It doesn't really matter for the remaining two. Okay? So here, how many ways do I have already? I already have 4 ways. And then I did this part without considering rotation or flipping. So let me finish let me make the circle a bit nicer first. I did this part without considering rotation or flipping. So if I consider rotation, it's a times 7 because there's 7 possible spots on a circle. If I consider flipping, I can have additional times 2 because I can do left-right flipping, right? So the final answer is equals to 56. Okay, number 13. Number 13, we have this nice question. Right, we have AB equals to BC equals to CD. Here, here, and here are the same. Angle A is 90 degrees and angle B is 150 degrees. Find the value of angle C in degrees. This question is in fact quite famous. I've seen this exact question before when I was a student. So I know what the exact solution of this question is supposed to be. The idea is that if you just look at the conditions given to you, it is not enough to deduce anything based on the ones given to us at the moment. So we need to create something a little bit imaginative. Okay, we need to create something a little bit imaginative. So the idea is we can make a parallelogram. Let's pretend that, okay, how do I draw a parallelogram? Is this a good one? Okay, maybe this is a bit more slanted, like that. Okay, let's pretend that we draw a parallelogram here. So let's call this point P. So we make sure that ABCP is a parallelogram. Now I might ask, what's the purpose of this? The purpose of this is that if I have this parallelogram right here, I know that in fact this angle is 30 degrees. So I know that this is 60 degrees. And in that case, I also know, because it's parallelogram, this thing and this thing are also the same length. So in fact, it's not just a parallelogram, it's in fact it's a rhombus, right? But the important part of the question comes when I take a look at the thing on the left, when I join the points D and P together. When I join D and P together, I notice I have actually an isosceles triangle over here. But not just that, this isosceles triangle has a 60-degree angle. So in fact, this is a equilateral. Triangle ADP is equilateral. Okay, so we know additionally, this is also the same length. And then we're done. Because once we know that this is the same length, we know that this is equals to 60 degree. We know that this is equals to 150 degrees. So we know that this is equal to 150 degree. And then we have an isosceles triangle. So immediately, we know that both of these angles here, they are equals to 15 degrees. Right? Together with the fact that this is equals to 30 degrees, I can combine them and say my final answer is 45. Question number 14. This question is quite a common question in our ratio and proportion worksheets. We have some questions which are all similar to this. It says, Mrs. Lim bought some pencils as gift for her three classes A, B, C. If she gave pencils to all three classes, each student will get 42. If she gives pencils to class A only, each student will get 105. B only will get 98. And if she gives to C only, how many will all three get? So the idea is that the total is going to be 42 times of the number of students in A plus the number of students in B plus the number of students in C, right? The total is going to be 105 times of the number of students in A, because if you give it to A only, this is 105 per person. If you give to B only, this is going to be 98 per person. So the question becomes, if you give to C only, then how many is it? Well, I want to use as minimal algebra as I can for this question. So in that case, I can look for a common multiple of 42, 105, and 98. I noticed that 42 is 237. I noticed 105 is 357. I noticed that 98 is equals to 27 squared. So the LCM is 2357 squared. If you go calculate out what this is, I believe is 1470. Let me just check first. Yeah, that's 1470. So what we're going to do in this question is that we can let the total be equals to 1470 units. Okay, 1470 units. Then we can go and find how many are each of them. So we can go and find, okay, A plus B plus C, 1470 divided by 42. Now you may find that not very nice to divide, but actually you can use this thing to help you divide, right? If you go 1470 divided by 42, the answer is 35, right? Because there's a 5 and a 7 left over. Then you can go and find out A is equals to 1470 divided by 105. So if you divide by 105, it's 14. And then you can go and figure out B is going to be 1470 divided by 97. If you divide by 97, you can cancel out the 2 and the 7 squared, that's 15. So therefore, the value of C is 35 minus 14 minus 15. That's equals to 6 units, right? So now, what is 1470 divided by 6? So 1470 divided by 6, you can cancel out the 2 and the 3 is 5 times 49. 5 times 7 squared is equals to 245. Is it? Yeah, it's 245. So that's the answer here. Okay, now let's move on to the last question, number 15. 15 is a little bit tedious of a question. All right. It says ABCD is a 4-digit number. The sum of squares of the digit is 33. Find the middle number if all such possible 4-digit numbers are arranged from smallest to largest. How many possible 4-digit numbers are there? The answer is there are many. So if you take a look at the digits, there are squares. The square of digits 0, 1, 4, 9, 16, 25. How to get 4 of them to add up to 33? Let's start from the largest, 25. Is it possible to have 25 plus something plus something plus something? The remaining must add up to 8, right? So yeah, there's a possibility. And this is the only one that has 25 because there's only one way to write 8 as the sum of 3 square numbers. What if I do 16? Then the remaining is add up to 17, right? So immediately you can see 16, 16, 1, 0 is a possibility. If the remaining adds up to 17, is there anything else? There's also 16, 9, 4, 4, right? 9 plus 4 is also 17. Now, what if I continue on the last case? If I start with a 9, then that one is not possible because 9994 is 31 and 9999 is too big. So therefore, there are only these 3 cases over here. Okay, so this one uses 0225, this one uses 0144, this one uses 2235. Wait, no, something's wrong. No, 2234, sorry. So how many numbers are there going to be? Quite a lot, right? Isn't it? So in fact, it will be good for us to honestly try to write out everything. You might think I'm kidding over here when I say try to write out everything. I'm not. Uh, I think that's the best way to do it. So let's start with the smallest. The smallest obviously will go from 1000, right? And it's everything that starts with 1000. How many are there? 1044, 1404, 1440. These are definitely the 3 smallest ones. And then we're done with the case where the first digit is a 1, right? Now let's move on to a case where the first digit is a 2. So you can do 20, 2025, 2052. These are possible. Okay. If I continue with a 2, any other cases, I can do 22. 2205 before 2234, before 2243, before 2250. Right. Okay. So okay, now I'm done with the 22s. Let's do the 23, 2324, 2342. Right. Let's do the 24s, 2423, 2432. Let's do the 25, 2502, 2520. Okay, maybe I should write on another column now. So we're done with the ones with first digit being a 2, right? Because I think I've written everything out already. Yeah. Then let's move on. So what happens if the first digit is a 3? So the smallest one will be 3224, then 3242, then 3422, right? These are the only ones that has the first digit being a digit of 3. Okay. And then we can take a look at those that start with a digit of 4. So those that start with a digit of 4, they have let's see, I can do 40 for a starting number, 4014, 4041. Right? So you are done with the 4 zeros. We can do 41, 4104, 4140. Again, I'm done with the four ones. Let's do the four twos. 4, 2, 2, 3, 4, 2, 3, 2. And I'm done with the four twos. Let's do the four threes. 4, 3, 2, 2. That's the only one. Right? And then next will be we're done with the four threes already. So we do the 4, 4, 4, 4, 0, 1, 4, 4, 1, 0. Right? And then next we move on to the fives, right? Because we have no more cases for fours. Okay. So fives, we have 5, 0, 2, 2, 5, 2, 0, 2, 5, 2, 2, 0. Yeah. And I believe that this is everything here. Okay. So if you don't want to write out everything, what you can also do is that you can just try to figure out how many cases there are based on the numbers given to you. For example, the first case here, let's do a quick check actually. All right. We are checking whether you have the right number of numbers. In the first case here, the 0 cannot be in the first position. Right. If the 0 is not in the first position, then the 0 can be in any of the other three, isn't it? So let's say the 0 is here. Then how many ways to arrange the 2, 2, 2, 5? There are 3 ways. Right. So in the first case, there are 9 ways. The second case, there are same thing, right? I can put a 0 anywhere. Let's say I put a 0 here, 3 cases for the 0. 1, 4, 4, also 3 cases, 9 ways. And finally, the last one here is equals to 2, 2, 3, 4. The 2 and the 2 repeats, so it's going to be 4 factorial divided by 2. This is 12 ways. So in total, there should be 30 numbers. Let's give a quick check, see whether we are correct. So let's count. 1, 2, 3, 4, 5, 8, 5, 10, 15. This is 20, 25, 30. Okay, 30, correct. Right. So we have all our 30 numbers here. Okay, where is the middle? The middle is right between the 15th and the 16th number, right? So this is the 15th number, this is the 16th number. So the middle numbers are 2520 as well as 3224. I think so, right? Yeah. Okay, so that's it. Uh yeah, we're done. Any questions you can ask now if you want to. Otherwise, I have nothing else for you. So the open round two we'll go through it soon, but not yet. The stream will start in maybe like a 1 hour's time around there. Yeah. So just stay tuned for that.